All right, so in 4B, we're going to go through a lot of different types of graphs to start with. Guys, you ready? First of all, the dot plot. When you draw a dot plot, you won't draw it in a box like this. Normally what you do is you draw one line, one axis, and you put numbers along that axis from your smallest value through to your highest value, and then you just put a dot above each number. When you're given the raw scores, you just put a dot for each one above, and that's a dot plot. So an 8 happened twice, a 0 happened 3 times, is what that means, dot plot. We also have our stem and leaf plot. The stem, usually, for most stem and leaf plots, the number on this left-hand side represents the tens digits, and the number on the right hand is your ones. So this would represent 68 and 104. Okay, so that's actually hundreds and tens digits, but anyway. It is possible to change that, which is why it is important here. It says remember to use a key. And to do that, you normally just take the first score that you're given. So I'm going to take that 68. It wouldn't be in the stem and leaf plot already. But you'd go, the number 68 is actually equal to a 6 line and then an 8. That's how we're going to put it in our stem and leaf. Because as I said, I could change that. If I wanted 6.8, I could also write that as a 6 line 8. It could be a decimal point instead of a tens and a ones. Okay, so depending on what the key is tells you how to read those numbers out of that stem and leaf. A column graph. Okay, you can see the column graph there. You often have categories down here on the bottom for a column graph, and then the frequency of the number of people that choose that category goes on your vertical axes. A histogram, okay, looks very similar. Couple of big differences. First of all, normally we have numbers on both of our axes, and we also don't have gaps between our columns, but that's not much difference, is there? They're very similar types of graphs. Okay, also in this exercise, you are going to have to calculate what we call summary statistics, which means we are going to be trying to approximate the middle or the center of our data. And the 3 methods that we have for doing that are our mean, median, and mode. So the word mean means to average. To find the average, you sum up all of the scores and you divide by the number of scores. Please be aware that there are some other symbols that you can use instead of having to write that out in words. I do need to fix this though, because that's not what yours says. It should look like that. So an X with a little line above it is the symbol that we use for mean. This symbol here, which looks a bit like a weird capital E, it's a Greek letter sigma, and it means to sum. Okay, that's what it means. I am summing all of my X values, all of my data values. Sum up all your data values is what that means. And the N is the number of scores. Okay, so that's the shortest way that you could write the formula. You're welcome to write it in words though if you want to. All right, next. I need to fix that symbol down there as well. The median. The median is our middle score. Often to do this, we write all our numbers from smallest to largest, and you'll probably remember doing the good old crossing off at the beginning and the end until you find that one score in the middle. Remember doing that? However, if you have lots and lots of scores, you don't want to do all that crossing out, or if all your scores are in a table, you don't want to have to do all that crossing out. So an alternative method to find the middle is this little, it's not really a formula, but more a process here to find where your middle score is. If you have got n scores, so that's how many scores that you've got in your data, so n could be 12. If I have 12 scores, you add 1 to that, which is 13, and you divide it by 2, which is 6.5. If you get a decimal number like I just did, 6.5, It means that your middle number is between the 6th and the 7th score. And you can just count through, where's my 6th number, where's my 7th number, and it's going to be between those two numbers. If when you average them, so let's say I had 15 scores, 15 plus 1 is 16, divided by 2 is 8, it means I want the 8th score. Can you remember that? So if you use this rule and you get a decimal, it means it's between the two scores. If you get a whole number, it is that score. And the third one is the mode, which stands for the most common score. Remember, they both start with MO, mode and most. That's how you remember it, mode and most. Okay, a couple of extra things here. Data can be symmetrical or skewed. For data to be symmetrical, you want it to look like it's perfectly balanced. So you might have 4 things here in the middle, and you want it perfectly balanced on either side. Okay? See that? Perfectly symmetrical. That's symmetrical data. Most of the time, data is a little bit skewed. And this is the annoying part. It's a little bit counterintuitive. I think it is anyway. Because check this out. If all of your data is kind of leaning to the right, which to me, that's kind of thinking as my numbers get bigger, and we're kind of thinking this is our positive direction this way, right? That's what I think anyway. That's actually called negatively skewed though. So when it's on the right-hand side, that's actually negatively skewed. When it's going more towards where our negative numbers normally would be, that's positively skewed. I don't know what genius thought they'd label them that way, but that's what they do. Okay, I guess, okay, this is why. Actually, no, that doesn't work either. I don't think it's the greatest, but that doesn't work either. So it's definitely counterintuitive, but that's how they've been named. And here is an example of a symmetrical one, similar to my one up here. It's close to symmetrical. It's not perfect, but pretty close to symmetrical data. So here's our examples. Question 1. For the following set of scores, find the mean, the median, and the mode. Okay, good old-fashioned. Here is some data. Let's find those things. To find the mean, remember that's the sum of the scores divided by the number of scores. So you're going to grab your calculators out and add up all those numbers, please. Come on.
44.
Good job, Maya. So just for practice, I'm going to put my symbol in here. Mean equals the sum of the scores was 44 divided by the number of scores. How many scores are in that there? 10. Great. So 44 divided by 10 is 4.4. That's my mean. Okay, the next one is median, which remember is middle. However, the scores have to be in order for us to do that, which they're not. So I need to go through and redo it. So I look through here, I go, where is my smallest number? Is 2 the smallest number?
Yeah.
Yeah, all right, so 2, starting at 2. And it's a good idea to cross them off as you go, just to make sure you use every single number. So there's 3 and 3, there's 2 3s. There's 4, 1 4. 1, 2, 3, 4 5s. And 6 and 6. Okay, I always, because if you miss a score, you will get this wrong. So you know there's 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you haven't missed any. It's always good to count those up at the end. Shh, same thing. Now, let's use our the one you're probably most familiar with, the crossing off method. We cross off from the beginning and the end. So the 2 and the 6, the 3 and the 6, 3 and 5, 4 and 5, and we keep going until we've either got 1 or 2 left. If you've only got 2 left, don't cross them off because we need them. The median is going to be between those 2 numbers because we've got 2 left in there. So because they're the same, it just means that my median is going to be equal to 5. If the numbers are different, you average them. So I can still average these. 5 plus 5 divided by 2 is still 5. Okay, you average the 2 numbers. Mode stands for most. So So it's easy to see the most when you've got them in order as well. So 5 happens 4 times. It definitely happens the most. So here is my mode. It's equal to 5 as well. And remember, Maya, that those scores, they're all different ways of approximating the middle, and they are all very similar. 4.4, my mean was a little bit lower than the others, but these ones both came out as 5. They're all very close to each other, usually. And the more symmetrical the data is, the more likely, the closer they're all going to be. On the next page, we want to do a slightly harder question than that. That was a little bit easy. Question 2, 20 students were asked how many phone calls they make on the weekend. The results are as follows. So this is my raw data. We want to organise the data into a frequency table using class intervals of 10, including a percentage column. So the table's in there for you. Sometimes you might have to draw that table yourself. So the typical columns are to have your class interval, your class centre, and your frequency. Only if it specifically asks for it do you need the percentage frequency one, and this one did ask for it, okay? So I've got the first couple of class intervals for you in there. We just need to continue that pattern. So from 0 to 9, 10 to 19. So continuing, 20 to 29, 30 to 39, 40 to 49. To find a class centre, you average the two numbers on the extreme ends of your class interval. So you go 0 plus 9 divided by 2. What's that? 4.5. Correct. Then you do it for the next ones. 10 plus 19 divided by 2. 14.5. Normally you only have to do a couple of them and you kind of see, whoop, there's a pattern here. They're going to keep going up by 10s. So it's going to be 24.5, 34.5, and 44.5. Now, another column that is not included in this one that you might sometimes have is a tally, which can be very helpful. This one doesn't have one, so we're going to have to do it a little bit the hard way. You're welcome to include a tally if you like, but let's try and do it without. I'm going to look through all of my scores in here and I want to count up all the ones that are between 0 and 9. So 1, 2, 3, 4, 5, 6, 7. You guys count 7? The ones I've highlighted, those numbers are all between 0 and 9. So 7, that's a frequency of 7. Go through your data again. And we now want to look for numbers between 10 and 19. Missed 18, there it is. I don't miss one. All right, so yes, you get 6. All right, next one. Go through and look for numbers between 20 and 29. Okay, so I get 4. Look for numbers between 30 and 39. So that's 2. And that just leaves the one last number, 42, which is between 40 and 49. There's an extra space down here at the bottom, which is to find our total. We just want to total up that column, so add those numbers up. Anyone done it? 20. Good. So that tells me there was actually 20, and we know that actually, it's up here. There were 20 students who were surveyed, and there was 20 results that I have in there, 20 people's answers in there. The last column, the percentage frequency. We take our frequency and we put it over the total, and to make something a percentage, what do? Yes, times it by 100. That's how you turn a fraction into a percentage. Girls? So the first one is 7 over 20, and I want to times it by 100. That makes 35%. You don't need to do that working out for everyone, but at least write it there for one so you know what you did. Go through and repeat that for all of them. 6 over 20 times 100.
30%.
Correct. 4 over 20 times 100.
20%.
2 over 20 times 100 is 10. And then 5%. And because these are percentages, hopefully logic tells us what should the total be.
100%.
Make sure it does, because then you know you haven't made a mistake. If you add up all those numbers, so 35, 65, 70, 80, 90, yep, 100%.
What happens if it doesn't?
Then there's a couple of things. If the numbers, these worked out beautifully, these numbers in here. It could just, if they're just a tiny bit out, it could just be from small rounding in here, and that's okay if they're a little tiny bit out. If they're hugely out, it means you've probably missed a score somewhere or you've messed up in your calculation, and go back and check. Okay, part B. We want to construct a histogram for the data showing both the frequency and the percentage frequency on the one graph. Can you guys see the dotted lines on there on yours? Yeah, you can? Good, yeah. Okay, so on the bottom axis down here it says data. That is going to be our scores. But remember, these are going to be columns. Okay, so which one do you think I should use? Should I use the class intervals or should I use the class center? Class center is usually the best one to use. So I'm going to use, have I got enough space? 1, 2, 3, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I put that here, I think I got plenty of space. So I'm going to put my class center there is 4.5. Then my next class center is going to be at 14.5. Then 24.5, 34.5, and 44.5. I could have stretched it out, but there it is. So the frequency is labeled here on the left-hand side. The frequency is this column here, and I don't need the total in that. The highest frequency I have is 7. I think you've got 1, 2, 3, 4, 5, 6, 7 labeled there nicely, little things there on the side. So we'll label those 1, 2, 3, 4, 5, 6, 7. Okay, before we sketch anything, let's also do our percentage frequency. Our percentage, again, not looking at the total, our highest frequency was 7. And it had a percentage frequency of 35. So this 7 here needs to be in the same line. This one here should be 35%. Okay, so make them the same height. Now, fortunately for us, that does work out nicely as a scale. That's 7 spaces and 35%. 35 divided by 7 is 5. It'd be going up by 5% each time. So 5, 10, 15, 20, 25, 30, and then 35 obviously for the top one. Now to finally draw our column graph, our histogram. So my class center of 4.5 has a frequency of 7. To draw the column, you start halfway to the 4.5. So it's got to be on either side. The 4.5 has to be right in the center of the column. So you start half on this side and half on the other side as well. So I'm going to go up here to 7, across the top, and down like that. Does that make sense? Ideally, you should use a ruler for this. If I see columns in a test that are really lopsided, then I have to deduct you marks. So use a ruler, please, where you can. The next one, 14.5, is frequency of 6. So the columns, remember for a histogram, they are touching. They're right next to each other, no gap. So straight across and halfway. You've got to go halfway between the 14.5 and the 24.5. Then the next one has a frequency of 4. And the next one's a frequency of 2. And the last one is a frequency of 1. Okay, and that is it. That's how you construct a histogram. Part C. Construct a stem and leaf plot for the data. Okay, we have got scores. Looking at the raw scores back up on the top of the page there, what's the smallest score that we had?
1.
I think there was a 0. 0, and the biggest score is?
42.
42. Okay, so that would work well to use a stem working in tens, wouldn't it? Because I would have a stem of 0, 1, 2, 3, and 4, and then I can fill in my leaf. Remember that you must have a key. So the first score in my data was the number 20, okay? So I'm going to go, the number 20 is going to be represented by a 2, then a line, then a 0. That's how you write your key. All right, now, you have a choice here. To draw a stem and leaf, the numbers that go in your leaf must be in order, from smallest to largest, and they need to be nicely spaced out. So the choice is that you can try to select, here's my numbers up here at the top, I'm going to get rid of all that highlighting. You can try to put them in order straight away, or you can draw the diagram twice. You can do it once where you just put them into the right category and then draw it again to order them. What do you want to do? You want to try and order them straight away, or do you want to do it twice and not risk missing any? No one has an opinion.
Order them straight away.
Order them straight away. Okay, May has made a decision. So the first group, my first stem, and you can see it's much easier because yours fits on your, you can see it on your page. I want to find all my stems of 0, which means numbers less than 10. So that's H2, 0, 1, 6, 5, any others? 2. Did I get them all? 1, 2, 3, 4, 5, 6, 7. Yep, got them all. All right, you need to put them in order from smallest to largest, trying to keep the same gap. So the smallest one was 0, so that's going to be 0, 0. Whoops, I need that one. The next one was 1, 2, 2, 5, 6, and then 8. 1, 2, 3, 4, 5, 6, 7 numbers. There they are. All right, so then you go back to your data again. We've used all those ones. Maybe you want to make sure they're crossed out so you don't use them again. Then we go through and we find all the numbers in the tens. So 1, 2, 3, 4, 5, 6 of those. Putting those in order will be 0, 0, 0, 1, 3, 8. Yeah, can you see what I mean? Yeah. Using the ones digits. All right, is this making sense? Okay, have a try of the 2 stem. There should be 4 numbers that you put in there. Anyone do it? Yeah, what did you get?
The 2.
Yep.
0, 2, 5, 8.
Correct. Notice as I'm constructing this that all of these numbers, you can almost draw lines, columns. These are in columns as they go down. It's very important that you do that. That way you can easily see where the numbers, how the numbers are skewed, if they're symmetrical, because you're keeping everything evenly spaced. The last couple of things that you should get would be 3 and 6, and then our 2 down the bottom. All right, one last bit, part D. Use your stem and leaf plot to find the median. Now, remember the crossing out method? You can do that for stem and leaf. You have to be really careful that you got to go to the right as you go across those rows, but when you're going from the back, you've got to go to the left. It's a little bit confusing. So how about we try out our other method, which was that formula that I gave you, which was n plus 1 over 2. Okay, so How many scores are in this stem and leaf here? Oh, that was short. You talk too much today. How many scores are in this stem and leaf? 20. So I want to go 20 plus 1 over 2, which is going to equal 10.5. Just wait. Shh, I'm nearly finished. That is not the median. That is the position of the median. It means that I need to find the 10th and the 11th score. So when I look through my stem and leaf, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 is that 0 and that 1. To find the median, I will add them together. So median equals 10 plus 11. Guys, just wait. Don't forget the stem when you add them. So that's 10 and 11. And you have to divide that by 2. And that is a really bad coincidence. So that equals 10.5. Because that was the same as that. That was a big coincidence. That shouldn't always happen. So you need to have a start on 4B for a little bit of homework, please.